Hello everyone and welcome. Have you ever wondered how your body is so smart? How it knows exactly where to drop off the oxygen you breathe in? It's not magic, it's biochemistry, and today we're talking about a tiny but incredibly important molecule called BPG. BPG stands for 2,3-bisphosphoglycerate, and it's the unsung hero of oxygen delivery. To understand BPG, we first need to talk about hemoglobin. Think of hemoglobin as the delivery truck for oxygen in your red blood cells. It picks up oxygen in your lungs, where there's a lot of it, and is supposed to drop it off in your tissues, like your muscles, where it's needed. The problem is, hemoglobin can sometimes be a little too good at its job. It can hold on to oxygen too tightly. This is where BPG comes in. BPG is a molecule found inside your red blood cells that acts as a regulator. Its main job is to decrease hemoglobin's affinity for oxygen. In simple terms, BPG tells hemoglobin, hey, it's time to let go of that oxygen. It does this by binding to the hemoglobin molecule, but only when hemoglobin is not carrying a full load of oxygen. This binding stabilizes hemoglobin in a shape, often called the T state or tense state, that is not good at holding oxygen. This makes it much easier for oxygen to be released precisely where it's needed most, in the tissues that are running low. So, why is this so important? Let's look at a couple of real-world examples. First, high altitude. When you go to a higher altitude, the air has less oxygen. Your body cleverly adapts by producing more BPG. With more BPG in your red blood cells, your hemoglobin becomes even better at releasing the oxygen it does carry, ensuring your tissues still get what they need to function, even with less oxygen coming in. Another fascinating example is the difference between an adult and a fetus. A baby in the womb needs to get its oxygen from its mother's blood through the placenta. For this to work, the baby's blood must be stickier for oxygen than the mother's blood. Fetal hemoglobin is structured slightly differently than adult hemoglobin, and it doesn't bind to BPG very well. Since BPG is the let-go signal, and fetal hemoglobin largely ignores it, it holds onto oxygen much more tightly. This high affinity allows the fetus to effectively pull oxygen away from the mother's hemoglobin, ensuring its own survival and development. So, in summary, BPG, or 2,3-bisphosphoglycerate, is a small but mighty modulator that fine-tunes oxygen delivery, making sure this life-giving molecule gets from your lungs to your cells efficiently, especially under challenging conditions. Thank you so much for watching. If you found this explanation helpful and want to learn more about the amazing world of biochemistry, please consider liking this video and subscribing to support the channel. It truly helps us create more content for you. We'll see you in the next video.